Stealth technology has fundamentally transformed modern military aviation, providing a strategic advantage by minimizing an aircraft's visibility to radar and other detection systems. The concept revolves around reducing an aircraft's radar cross-section, RCS, making it harder for enemy forces to detect and track the aircraft. This has been achieved through a combination of specialized design, radar-absorbent materials, and advanced avionics. Stealth technology first gained prominence during the Cold War era, with developments in the 1970s and 1980s leading to the creation of aircraft like the F-117 Nighthawk. The F-117 was the world's first operational stealth aircraft, designed specifically to evade sophisticated radar systems. Its unique angular shape and flat surfaces, combined with radar-absorbent coatings, minimized the reflection of radar signals, rendering the aircraft nearly invisible to enemy detection. This technological leap not only gave the U.S. military a significant advantage in missions where air superiority could not be easily established, but it also influenced the future design of stealth platforms, including advanced fighters like the F-22 Raptor and F-35 Lightning II. As adversaries continue to develop their own radar and surface-to-air missile (SAM) systems, the race between stealth technology and countermeasures remains at the forefront of modern warfare. The F-117 Nighthawk holds a pivotal place in the history of military aviation, being the world's first operational stealth aircraft. Developed by Lockheed Martin during the 1980s, the Nighthawk was designed with one primary objective: to evade radar detection and conduct precise missions in contested airspace. The aircraft's distinctive appearance was not for aesthetic purposes. Rather, its angular, flat-panel design served a functional purpose, reducing its radar cross-section to an absolute minimum. By minimizing the reflection of radar waves, the F-117 was virtually undetectable to enemy radar systems, allowing it to fly deep into hostile territory with little risk of interception. The aircraft's use of specialized radar-absorbent materials further enhanced its stealth capabilities, absorbing rather than reflecting radar signals. This made the Nighthawk an ideal platform for precision strike missions against high-value targets, such as command centers, radar installations, and critical infrastructure, without leaving a substantial electronic footprint. Its low, observable characteristics, combined with sophisticated avionics and weapon systems, revolutionized the way air campaigns were conducted, offering a level of survivability unmatched by traditional aircraft. During its early operational deployments, including the Gulf War and later missions in Kosovo, the F-117 demonstrated the effectiveness of stealth technology in reducing the vulnerability of aircraft to increasingly advanced air defenses. The success of the Nighthawk set the foundation for future generations of stealth aircraft, shaping modern military doctrine and paving the way for more advanced low-observable platforms like the F-22 Raptor and F-35 Lightning II. The Kosovo conflict of 1999 was a significant geopolitical event that highlighted the importance of air power and advanced technology in modern warfare. The situation arose from ethnic tensions between ethnic Albanians seeking independence from Serbia and the Serbian government's brutal crackdown on dissent. As a result, NATO, led primarily by the United States, launched an air campaign to force Serbia to comply with international demands and halt the human rights abuses. This conflict marked one of the first large-scale uses of stealth technology in a modern combat environment, with the F-117 Nighthawk playing a critical role. During the Kosovo conflict, air superiority was essential for NATO to achieve its objectives, and stealth technology was at the forefront of this effort. The F-117 Nighthawk, with its advanced stealth capabilities, allowed NATO to strike high-value targets deep within Serbian-held territory without being detected by radar systems. Its ability to evade sophisticated air defenses, such as surface-to-air missile systems (SAM), made it an invaluable asset. The Nighthawk's radar-absorbing materials, angular design, and specialized avionics made it virtually invisible to enemy radar, providing NATO with a distinct advantage in missions against heavily defended targets. However, the conflict also exposed the limitations of stealth technology when facing increasingly advanced air defense systems. Serbia, with the assistance of Russia, had modernized its air defense capabilities, incorporating older but effective radar systems such as the SA-3 and SA-6. These systems have been adapted and upgraded with more advanced tracking technologies, allowing them to detect low observable platforms like the F-117. As a result, NATO forces had to contend with the challenge of balancing stealth operations with the evolving capabilities of these air defense networks. On March 27, 1999, during one such mission near Belgrade, an F-117 Nighthawk was shot down by a Serbian SA-3 missile. The missile's success underscored the vulnerability of stealth aircraft when confronted with enhanced radar and missile technology. The incident served as a wake-up call for NATO, pushing the alliance to further refine its tactics, develop better countermeasures, and adapt to the growing capabilities of air defense systems. The Kosovo conflict remains a testament to the ever-changing dynamics of modern warfare, where advancements in stealth technology and countermeasures must constantly evolve in response to new challenges. The F-117 Nighthawk played a pivotal role in shaping modern aerial combat during its deployment in various conflicts, particularly in the Gulf War and later during the Kosovo conflict. As the first operational stealth aircraft, its primary mission was to deliver precision strikes against high-value targets in contested environments with minimal risk of detection. The Nighthawk's unique design, featuring sharp angles and radar-absorbent materials, made it nearly invisible to enemy radar systems. This ability allowed it to operate deep within hostile territory, targeting critical infrastructure such as command centers, missile sites, communication hubs, and supply lines with unparalleled accuracy. During its initial operational deployment in the Gulf War, the F-117 proved highly effective in executing precision strikes on key strategic targets with limited collateral damage. By flying at low altitudes and employing advanced navigation systems, the Nighthawk could deliver its payload with extreme precision. The success of these missions demonstrated how stealth technology could transform air warfare by reducing both the risk to air crews and the visibility of military operations. Additionally, the F-117 allowed the U.S. military to bypass heavily fortified air defense networks without triggering an immediate and overwhelming counterattack. However, the limitations of the F-117 became apparent during the Kosovo conflict in 1999. While still effective in its mission of delivering precision strikes, the increasing sophistication of Serbian air defenses, including modern radar-guided surface-to-air missile systems, exposed vulnerabilities in its stealth design. Despite its advanced features, the aircraft was vulnerable to older but well-maintained systems that had been updated with better tracking capabilities. The eventual downing of a F-117 by a Serbian SA-3 missile system highlighted the necessity of adapting tactics to counter emerging air defense threats, forcing NATO to refine its use of electronic warfare and other countermeasures. Despite these limitations, the F-117 remained an essential tool for U.S. and allied forces in various missions, continuing to demonstrate the strategic importance of stealth technology in modern warfare. The aircraft's successes and eventual challenges laid the groundwork for the development of more advanced stealth platforms like the F-22 Raptor and F-35 Lightning II, which incorporate even more sophisticated technologies to combat evolving threats. During the Kosovo conflict in 1999, Serbia's air defense capabilities were significantly enhanced with the assistance of Russia, which provided modern surface-to-air missile systems and advanced radar technology. The increasing sophistication of these systems presented a serious challenge to NATO forces, particularly stealth aircraft like the F-117 Nighthawk. While stealth technology had proven effective in bypassing older radar systems, the integration of newer, more advanced air defense systems forced NATO to continuously adapt its tactics and technology. The Serbian military was equipped with a variety of missile systems, including the SA-3, SA-6, and later the more advanced SA-8 and SA-9 systems. These older systems had been retrofitted with upgraded guidance systems and improved tracking capabilities, allowing them to detect and engage low observable platforms, such as stealth aircraft. The SA-3 system, in particular, was able to target stealth aircraft like the F-117 with some success, as it was adapted to use improved radar and signal processing technology to track and intercept low observable targets. Moreover, Serbia utilized a comprehensive approach to air defense, integrating radar coverage with other forms of detection, such as infrared and electro-optical tracking systems. This multi-layer defense made it increasingly difficult for stealth aircraft to operate unimpeded, as each layer worked together to provide a more accurate picture of the aircraft's movements. Additionally, Serbia's ability to incorporate electronic warfare (EW) capabilities further complicated NATO's missions, as enemy forces could disrupt communication and navigation systems used by stealth aircraft. These advancements in Serbian air defense technology were a direct response to the perceived threat posed by stealth aircraft, and they significantly shifted the dynamics of air combat during the Kosovo conflict. NATO's challenges were further compounded by the growing integration of anti-aircraft systems with ground-based intelligence and reconnaissance operations, which enhanced the ability to detect and neutralize even the most advanced stealth platforms. This technological arms race underscored the importance of ongoing research and development in stealth technology and countermeasures to maintain dominance in contested airspace. The downing of the F-117 Nighthawk on March 27, 1999, during the Kosovo conflict was a pivotal moment in the evolution of stealth technology and modern air warfare. Although stealth aircraft like the F-117 were designed to evade radar detection, the Serbian military's increasingly sophisticated air defense systems managed to detect and engage the aircraft. This event marked a significant challenge to the invincibility of stealth technology, demonstrating that even advanced low-observable platforms could be vulnerable when confronted with well-coordinated and modern air defense networks. On the day of the incident, an F-117 was targeted by a Serbian SA-3 missile system near Belgrade. Despite its advanced design and specialized radar-absorbent materials, the aircraft was intercepted because Serbia had improved its radar capabilities. The SA-3 missile, which had been upgraded with more advanced tracking and guidance systems, was able to lock onto the F-117 and successfully strike it. This shoot-down was the first combat loss of a stealth aircraft in history and sent a clear message that stealth technology was not infallible, especially when facing increasingly capable adversaries. The F-117's downing highlighted the limitations of relying solely on stealth to achieve air dominance. While stealth aircraft could avoid traditional radar detection, they were vulnerable to other advanced technologies, including electronic warfare, infrared tracking, and multi-layered air defense systems. Serbia's use of these methods exposed gaps in the stealth paradigm, forcing NATO to reassess its strategies and tactics. Moreover, the incident underscored the importance of integrating electronic warfare with traditional military operations. By disrupting communications, navigation systems, and jamming radar signals, Serbia was able to reduce the effectiveness of stealth aircraft and increase the likelihood of intercepting them. The shoot-down of the F-117 prompted an immediate response from NATO, leading to adjustments in stealth technology, the development of more advanced countermeasures, and the exploration of alternative tactics to ensure the survivability of future stealth platforms. The downing of the F-117 Nighthawk during the Kosovo conflict in 1999 had significant implications for the future of stealth technology and military operations. One of the most critical lessons learned from this event was the recognition that stealth alone was no longer a guaranteed method of achieving air superiority. While stealth technology had previously provided an unparalleled advantage in avoiding detection and engaging targets, the advancements in radar and surface-to-air missile systems necessitated the evolution of countermeasures and tactics. The shoot-down of the F-117 demonstrated that adversaries were increasingly capable of developing systems to detect and track low-observable aircraft. Serbian air defense forces, with support from Russia, had modernized their radar systems and integrated advanced technologies, such as signal processing and multi-layer defense networks, which made it possible to overcome the weaknesses of traditional radar systems. This forced NATO to rethink its approach to employing stealth aircraft in contested airspace, as the challenge was no longer just about evading radar, but about understanding and countering an adversary's ability to adapt. In response to the downing of the F-117, the U.S. military accelerated the development of more advanced stealth platforms, such as the F-22 Raptor and the F-35 Lightning II, which incorporate even more sophisticated radar-absorbent materials better electronic warfare capabilities, and improved situational awareness systems. These newer aircraft have enhanced stealth features that extend beyond traditional radar evasion, incorporating sensors that detect threats and provide real-time countermeasures to mitigate them. Additionally, the incident highlighted the importance of integrating electronic warfare, EW, into stealth operations. Electronic warfare capabilities became a critical component of mission success, as adversaries continued to develop systems to disrupt communications, navigation, and radar systems used by stealth aircraft. By leveraging advanced EW systems, stealth platforms can create windows of opportunity where they can operate undetected, ensuring mission success while minimizing the risk of exposure to adversarial defenses. The F-117 shoot-down also underscored the necessity of intelligence gathering and real-time situational awareness. Successful operations in modern warfare require a comprehensive understanding of the enemy's capabilities, tactics, and evolving technology. The combination of advanced reconnaissance, data fusion, and real-time information sharing became paramount to effectively countering the threat posed by advanced air defense systems. In summary, the downing of the F-117 led to a reassessment of stealth technology and its role in future military operations. It highlighted the need for continuous innovation in stealth design, integration of advanced countermeasures, and the development of collaborative strategies that combine multiple layers of defense to maintain dominance in contested airspace. The downing of the F-117 Nighthawk during the Kosovo conflict had a profound impact on military strategy and the development of future combat doctrines. For decades, stealth technology had been seen as a game-changer, offering a strategic edge in air warfare by allowing aircraft to operate undetected deep within enemy territory. However, the shoot-down of the F-117 demonstrated that stealth alone was no longer sufficient to ensure mission success in modern, contested environments. This realization forced NATO and other military forces to reconsider how they approached air operations, integrating a more comprehensive set of tactics, technology, and intelligence capabilities to maintain dominance. One of the immediate shifts in military strategy was the emphasis on incorporating electronic warfare, EW, capabilities alongside stealth operations. While stealth aircraft like the F-117 could evade radar detection, sophisticated adversaries were developing countermeasures such as signal jamming, radar-guided missiles, and infrared tracking systems. The downing of the F-117 highlighted the vulnerability of stealth aircraft to these increasingly advanced defenses, necessitating a holistic approach that combines stealth with electronic countermeasures, cyber warfare, and adaptive tactics to outmaneuver enemy defenses. Additionally, the F-117 shoot-down emphasized the importance of situational awareness and real-time intelligence gathering. In modern conflicts, battles are often fought in dynamic and fast-changing environments, where data from sensors, reconnaissance, and intelligence feeds must be fused seamlessly to ensure effective mission execution. As a result, military operations shifted toward a more integrated approach where stealth aircraft are supported by a robust network of assets that provide comprehensive information on enemy movements, threats, and potential vulnerabilities. Another key consideration was the need for continued development of more advanced stealth platforms with improved survivability features. Subsequent generations of stealth aircraft, such as the F-22 Raptor and F-35 Lightning II, incorporated enhanced radar-absorbing technologies, more advanced avionics, and the capability to detect and counter threats autonomously. These newer platforms were designed not only to avoid detection, but to actively engage and neutralize threats through a combination of stealth, sensor fusion, and autonomous weapon systems. The Kosovo conflict also influenced the evolution of joint operations across different domains, such as land, sea, air, and cyber. In this interconnected battlefield, the success of stealth operations is increasingly dependent on cooperation between various military branches and the integration of information technology. This required the establishment of more agile, adaptive command and control structures that could quickly respond to the challenges posed by modern air defense systems. In summary, the downing of the F-117 forced a paradigm shift in military strategy. Stealth technology became part of a broader approach that prioritized multi-domain operations, intelligence-driven decision-making, and integrated systems to counter the evolving threats posed by advanced air defenses. The evolution of air defense technology has been a critical factor in shaping modern military operations, particularly in response to the increasing use of stealth aircraft like the F-117 Nighthawk. As stealth technology advanced in the late 20th century, adversaries recognized the need to develop more sophisticated radar and missile systems to counter these low-observable platforms. During the Kosovo conflict, Serbia's adaptation of older but upgraded air defense systems highlighted this trend. The success of the SA-3 missile system in downing the F-117 demonstrated how adversaries could exploit even incremental advancements in radar and missile technology to neutralize stealth aircraft. Over the years, air defense technology has grown more sophisticated, with a focus on enhancing radar detection, tracking, and missile interception capabilities. One significant area of advancement has been in phased array radar systems, which provide greater range, accuracy, and the ability to track multiple targets simultaneously. These systems employ active electronically scanned arrays, AESA, that allow for rapid adjustments to detect low observable aircraft, adjusting frequencies and waveforms to improve detection efficiency. Additionally, advances in signal processing technology have enabled radar systems to distinguish between real threats and electronic clutter, reducing the chance of false positives while increasing detection accuracy. Surface-to-air missile systems have also evolved, incorporating advanced guidance systems that enable them to track and engage stealth targets. Modern systems, such as the SA-15 and SA-20, feature enhanced tracking capabilities that can lock onto stealth aircraft using advanced radar guidance algorithms and multispectral sensors. These missile systems have adapted to improve their ability to target low observable platforms, utilizing improved command guidance and advanced warheads that ensure destruction of hard-to-detect aircraft. Furthermore, electronic warfare, EW, has become a critical component of modern air defense. EW technologies are employed to disrupt radar, communication, and navigation systems used by stealth aircraft. Jamming systems, spoofing techniques, and electronic deception are increasingly integrated into air defense networks to reduce the effectiveness of stealth capabilities. By targeting radar and communications, adversaries can create windows of opportunity to engage stealth aircraft when their ability to navigate and communicate is compromised. In addition to radar and missile advancements, advances in satellite and ground-based sensor technology have significantly enhanced air defense capabilities. Reconnaissance satellites and drone-based sensor systems provide real-time intelligence, allowing ground forces to detect and track stealth aircraft from long distances. These developments have created a more comprehensive, layered approach to air defense that incorporates multiple detection methods to ensure that even low observable platforms cannot operate without risk. The continuous evolution of air defense technology has forced military strategists and defense contractors to innovate in parallel with adversaries, pushing the boundaries of stealth technology, electronic warfare, and multi-domain operations. As adversaries develop increasingly advanced systems, the challenge for military forces is to maintain technological superiority through persistent innovation and collaboration between various domains of defense. The downing of the F-117 Nighthawk during the Kosovo conflict in 1999 has had significant long-term implications for the development and deployment of stealth aircraft. While stealth technology revolutionized air combat during the late 20th century, the increasing sophistication of enemy air defense systems has necessitated continued advancements to ensure the survivability of these platforms. The lessons learned from the F-117 shootdown have driven the evolution of stealth design, highlighting the need for more advanced systems that combine stealth with resilience against emerging threats. One of the primary future implications for stealth aircraft is the ongoing development of more sophisticated radar-absorbent materials and shapes. The original F-117 utilized a basic angular design to deflect radar waves, but newer stealth aircraft, such as the F-22 Raptor and F-35 Lightning II, incorporate advanced stealth features like adaptive surfaces and advanced coatings that further reduce radar cross-sections. These newer platforms are designed not only to evade detection, but to actively counter increasingly advanced air defense systems through a combination of stealth, electronic warfare, and sensor fusion. Additionally, artificial intelligence, AI, and machine learning have become critical components of future stealth technologies. By integrating AI, aircraft can autonomously adapt to changing battlefield conditions, making real-time adjustments to their stealth features, sensor operations, and countermeasure strategies. AI-driven systems can continuously analyze and assess threats, optimizing defensive and offensive tactics without requiring constant human input. This evolution enhances the effectiveness of stealth aircraft in dynamically contested environments, where adversaries are constantly refining their detection and interception capabilities. The development of swarming and collaborative stealth operations is another area of growth. Future stealth platforms may operate in coordinated formations, using a network of low-observable drones, manned aircraft, and support platforms to create a distributed, multi-layered force. This approach allows for redundancy and adaptability, minimizing the risk of any single aircraft being compromised, while still overwhelming enemy air defenses with overwhelming numbers and technological superiority. Furthermore, the shift towards multi-domain operations requires stealth aircraft to be more integrated across different branches of the military: air, land, sea, space, and cyber. Stealth platforms are increasingly required to operate seamlessly in a joint environment, sharing intelligence and collaborating with other systems to achieve mission success. This broader scope enhances their versatility in both conventional and unconventional warfare, enabling coordinated strikes against targets that span multiple theaters. Lastly, advancements in countermeasures are shaping the future of stealth operations. As air defenses continue to evolve, the development of countermeasure technologies, such as advanced jamming, spoofing, and decoy systems, ensures that stealth aircraft can maintain a tactical advantage. These systems are designed to disrupt enemy detection and interception efforts, thereby ensuring that stealth platforms can continue to operate effectively in high-threat environments. In conclusion, the F-117 shoot-down during the Kosovo conflict highlighted the vulnerabilities associated with early stealth technology, but it also set the stage for the continuous evolution of stealth aircraft. With advancements in materials, AI, multi-domain operations, and countermeasures, future stealth aircraft are poised to remain a critical component of modern military strategy, providing unmatched survivability and operational capabilities in the face of ever-advancing threats.